Welcome. In this video, we're going to focus on the char or the character data type in Rust. And what the char data type helps us to do is to store Unicode scalar values. So let's take a look at what Unicode is in the first place. So I'm going to open my browser. I'm having a hard time opening my browser here. Yep. Okay. So if you go to home.unicode.org, they say everyone in the world should be able to use their own language on phones and computers. So basically, Unicode is a standard way that helps the representation of characters from different languages on a computer in a way such that, it is a standard so that it works across different devices, different operating systems, different programming languages, and different hardwares. And a very simple summary I can give you is that Unicode assigns a unique integer to each character you can see on a computer, on a phone, or some other electronic devices, and we are able to represent these in our programming statement using the char data type. Okay, so you can read more about Unicode. Now, the way we declare a character is we say I'm going to call it ch, and I'm going to say the data type is char, and I'm going to store the character a in it. Okay, now with this I can come here and we can do our usual stuff, printing our character. So let's print it out and see what's in there. And unsurprisingly, we expect to see the very character that we have placed in there. So let's come down here, do cargo run, and you can see that we have char is equal to a over here. Okay, and each character takes 4 bytes to represent itself in your computer's memory. 4 bytes, and that is how the Unicode standard operates. And they chose 4 bytes, which is also 4 times 8, which is 32, because that allows them to represent all the characters from the different languages across the world so that nobody is left behind. Okay, so let's see how you can print out the number of bytes or the size in bytes that a particular value is occupying in memory. I'm using the char as an example, but it applies to all the data types that you have learned about up until this point and the ones that you learn after this video. So the way to import in Rust is to use the use statement. So I say use std mem, and so this mem thing here is we will get to using importing statement, but the use statement here is bringing in some code that will help us to get the size of a particular value to know how much byte it is occupying. So I'll come here and I'll print ln, and I will say I want to print that the character occupies, and then I'll put the number of bytes here. So it occupies this byte. So I'm going to put here our ch, and I'll call mem, and then it's called size of value. Okay, so you call size of value, and then you provide a reference to the value whose size you want to get. So the way we get a reference is to use the ampersand. These are all things that we'll be talking about, but this is for demonstration purpose. And so let's go ahead and verify that this indeed occupies 4 bytes in memory. So you can see that it says A occupies 4 bytes in memory. Okay, and because characters map onto Unicode scalar values, which are also unique integers that are assigned to these characters on our keyboards, on our phones, and other electronic devices, it is easy for us to convert from a character to an integer. And the way we can do that is, if I want to see what unique integer is assigned to the small letter a in Unicode, all I have to do is this. So I'll say print ln, and I'm going to say so a has okay, I'll say a, or the char is blah 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 in Unicode. Okay, and so over here I'm going to bring my ch, and here I'm going to say ch as I32. because Unicode code points are also I32 numbers. They are integers that are assigned to these characters. So let's see what integer is assigned to small letter a, and that is 97. And as you can imagine, if I change this to b, it should change what character? That is 98. And if I change it to capital A, what do we have here? That is 65. So what do you think is going to happen if I put in a number over here? Let's compile it and see. And you can see that 2 has the Unicode code point, Unicode scalar value 50. This shouldn't surprise you. So this 2, because it is in single quote, is not an integer, it is a character. And based on the Unicode representation, whenever you type this character on your keyboard, in the Unicode standardization, what is seen is actually this Unicode code point 50. Okay, so this is it about characters for representing Unicode scalar values. They take 4 bytes in memory, and you can easily convert them into integers. And the way we do that is to use the as keyword. This is something we'll talk about to learn more about data type conversions, but I had to use this to let you know what's possible with this particular data type. So thank you very much for watching, and I'll see you in the next video.